So all I'm going to talk about today is the classes that we have on offer at Columbus Community College in computer science, and a couple IS classes that are kind of related to what I teach and to programming. So we've got 3.5 years of computer science here at Columbus Community College, of which these four are sort of the core curriculum. Basically, every place that you are going to transfer to is going to require oh, that's readable. Maybe it is. I don't know. It's going to require these four classes. So if you're going to go to UC, you're going to need to complete all four of these classes, and they will transfer 3 out of the 4 of them. Every UC has their own class that they don't transfer, and they're all different. So it's not like even like there's something we can do about it. It's just literally like a lot of the times we're just like we want transfer students to take one lower division class so that we can take a look at them and make sure that they know what they're doing. So yeah, Nero here is at Nero is at UCLA, right? Nero, do you leave? Yeah. Okay. I was gonna ask him which ones transferred there, but like sometimes in fact I think with him they transferred all of them, which was nice, but it's just such a weird system that you can't count on it. So these are the 4 core classes. And so you're in CSI 40 right now, Introduction to Programming. And by now, you basically know everything in computer science, at least as far as programming goes. There's one kind of major topic we haven't hit yet, which is classes and how to program, and what's called an object-oriented style is really going to be continued into CSI 41. So really, by the end of CSI 40 and 41 together, you guys will actually have enough programming knowledge to get a job as a junior developer. I personally worked in the industry after having just taken these 2 classes. And after that point, you're expected to know how to program. Now, you might not be good at it. You obviously need more practice, but you are not going to be taking classes anymore where they're like, this is a semicolon. This is the curly brace. They're going to assume you know how to program. They understand you're going to make mistakes and things like that, but like they don't need to explain to you what a variable is and to explain to you what a for loop is. Like they're like, you know that already, and now we're going to move on. Computer science is a 4-year career. Learning to program is really just the first 2 semesters of it. After that, you're not learning to program anymore. You're doing things with programming. Okay. So, for example, in discrete math, you are going to learn how to do things like find the shortest path from one point to another. If you have obstacles and things like that, Google Maps would be an example of this. Like, how do you navigate from Los Angeles to New York? How do you navigate from Fresno to San Francisco in the shortest distance possible, or the shortest amount of time possible? That is a algorithm that you're going to learn in CSI 26. 41 is going to cover things called data structures. Data structures, you've learned 2 of them, or 3 if we count arrays, which I'm not going to. You've learned 2 of them so far, which are vectors and hash maps. And those are my favorite data structures. That's why you've learned them in 40. A lot of colleges don't teach hash tables till junior year, which I think is way too late, because they're amazing. They're great. They're awesome. So you're going to learn more ways. A data structure is something that holds many, many variables, and you're going to learn all sorts of different data structures in that class, like stacks, queues, linked lists, decks, binary search trees. We'll go over hash tables probably again. But also a lot of 41 is just like what's in the standard library, and stuff like that. So there's a fair amount of like how to program in that class, and then a fair amount of like data structures and when you use one versus using another one. When do I use a linked list? Never. That's the answer. When do I use a vector? When do I use a hash table? When's the right time to do them? And that's CSI 41. Then CSI 26 is a lot of math. When I took it, it was 20 weeks of nothing but math, no programming whatsoever, which I thought was a crying shame. I feel like the best way of learning a topic is to program it, rather than just reading about how to do shortest path. Well, you write a shortest path program. It's not hard. Maybe 5 lines of code to actually do the algorithm. Maybe even less. Ballpark 5 lines of code. Maybe 10. I don't know. it's not like pages and pages of like, stuff. It's actually a fairly short algorithm. But like when you code it, then it sticks in your head. So a lot of math and discrete math, but we also do a lot of programming in that class too. It's an opportunity for me to teach you guys some of the more advanced topics inside of C++ and things like that. 5 lines without all the boilerplate, yeah, and without doing the input, just like the actual Dijkstra's algorithm is, ballpark 5 to 10 lines of code for the actual, like Dijkstra-ing of it. Then CSI 45 is a little bit different than the other classes because part of it is going to be talking about assembly, but part of it is going to be talking about computer architecture. And computer architecture is not math, it's not programming, it's just like what happens inside of your computer. So Aaron calls it the fun class. It is. I have a lot of fun in 45. It is a lot of fun to teach, and I think it's a lot of fun to take because of the projects more than anything. But computer architecture is like answering that age-old question of like, what exactly is happening inside of this magic box that has a CPU and RAM and stuff like that. Like we all know, oh, the CPU is the brain of the computer. Okay, great. How does it actually work? And how does, like when you type a.out and run and hello world appears on the screen, what's actually happening? Like what's going on underneath the scenes there? And when you learn how computers work under the hood, you can actually write better programs that match the architecture and things like that. So about a third of the class is in computer architecture. About a third of it is assembly, which is the lowest level programming language that humans typically program in. Your C++ code turns into assembly code. It's the language spoken by the CPU. We typically don't write very much assembly these days. Some people do. It's a fun hobby for some people. But mostly it's generated by compilers these days. But you still need to be conversant in assembly because a lot of the times you will actually look at the assembly output of your program and see if it, makes sense, or there might be some really obvious optimization that you could do and make it run 30% faster with just a little bit of effort. So nobody writes like Roller Coaster Tycoon these days, which was like something like 45,000 lines of assembly code, just the entire game, graphics, everything in like assembly, which was widely considered the work of a mad genius. Yeah, in embedded systems, things like that. Like it's not like assembly is like useless. It's just it's more niche than like learning to program. Right? Like, everywhere you go in life, even if you're a math major or a physics major, you're going to need 40 and 41. Okay. Even if you're not going to work in computer science, I think everybody should take 40 and 41. And if you are going to work in computer science, that's, like I said, when you can get your first job doing programming. Now, the fun part of 45 is the projects. So we have a lot of really fun projects that we do every semester. Last semester we did sentry guns, and somebody built an Orbeez gun that would rotate and has a little ultrasound sensor on it, and could find a target and shoot Orbeez at it. Had a range of like 3 meters or something. Like it had a pretty substantial range. It was really accurate too, and it was all themed out like Plants vs Zombies. And so we give points for like artistic merit as well. It's kind of like this image processing thing that we did today. Like you get judged on like the presentation of your thing. It's like a little pea shooter. Yeah, Orbeez are like little jelly balls, and the thing was like hitting the wall and like shattering, and like little pieces of like jelly were like getting my hair and like down my shirt, but like that thing was really well made. And we've done art projects where like we have interactive art, so like you walk up to it and the pirate ship goes ahoy, and these little doors open up and cannons wheel out and a fan turns on and the sails on the ship start billowing and it plays the sound of like cannons firing at you and stuff like that. Like it is there's just the creativity of students. Carnival games, we do carnival games where like you have you can make it however you want. Like some people did whack-a-mole, some people did like a little laser shooter gun where they have a laser sensor and a laser pointer and turn it into a gun, and they played Atom Bomb Baby while these bombs are moving up and down, or they're supposed to be moving up and down. I think they didn't get that part working, and you shoot at them to get points and stuff like that. So holographic projector is what Aaron did. There's just been a whole lot of creativity in that class, and it's a lot of fun. So the projects here is like the most fun I have teaching computer science. It's just a lot of fun. It's a lot of work, but did a cat just walk past? I think it did. Hey, Louie, come here. Kitty. It's not our cat, by the way. How you doing, kitty? Hey. Doing good? Yeah? Are you good, Louie, today? I think so. You haven't peed in here, have you? That's good. Yeah. It's our neighbor's cat. He just likes coming to our house. So, it's not my cat at all, no. He just, like, he'll sneak into our house every chance you get. Like, you open the door, like, taking groceries, he darts inside. He just loves us, I don't want to tell you. So, open door policy, we try not to. Like, yeah, you know, like, put down our groceries, like, he runs around it, comes inside. He just likes hanging out with us. He's a super friendly cat. You want to see him? You guys want to see the cat? Louie. Where'd you go? Louie. Louie. Ah, there he is. Hey, to hold up Louie to the camera so that people can see not our cat here. Or, over here. Yeah. Louie. Not our cat. Not our cat. He's just adopted us.
We feed him, we pet him, we love him, we let him into our house, but he's not our cat.
Not our cat. He's our neighbor's cat. He just loves us. Sweetheart. Okay. So what was I saying? He is like the nicest cat I've ever met. Like I met him like I was just walking around the neighborhood, and he just like comes up to me, and I'm like, oh, what's up with this cat? Like it was like so friendly. I was like, whoa, whoa, whoa. Cats are not supposed to behave this way, you know? And it just like I'll go for a walk around the neighborhood. He just walks with me. So like I'll just do a lap around the neighborhood, and he just like trots with me like lap after lap around the place. So he's not even a stray. Like he's owned by the people 4 doors down. He just loves hanging out with us. Okay, so that's the core curriculum. If you want to take CSI 1, that counts as a critical thinking class. So it's a GE at our college to take critical thinking. You take the GE as part of the philosophy department, sociology department, or computer science department. So we have a critical thinking class. It's also for people that are like kind of like struggling in CSI 40. Like we teach the basics of programming and kind of like do a really easy, gentle introduction to computer science in CSI 1. So taking that before 40 is good for people that are really like not technically oriented, you know. But then a lot of people take this like after taking assembly, you know. So like half my students are like third-year students, and then half of them are like 0-year students. And so I'll usually give like different programming assignments to the different groups. Okay, and then a bonus thing you can do is I teach this every semester, and I teach it every summer. The only class I teach during the summertime actually is game dev. And so game development is part of the IS department, is not part of the computer science department. I don't know what the difference is, honestly. They're just different departments. But IS 50 is game development. And we have A and B, first semester, second semester. And so we do game development in Unreal Engine, in Game Dev 1, and then we do game development. IS is information systems. And what is. And so in CSI Extended, yeah. Exactly. So a lot of computer science people take it to enhance their computer science knowledge. Like Game Dev 1, I think is actually really good to take after taking CSI 40. Because it covers a lot of the same topics, except you're doing it visually and in code, visual code. programming games, and that just makes everything interesting. You have a for loop, like produce 7 bullets or whatever, or something like that. You get to visually see, everything that's happening. And I think IS-50A is a lot of fun. We talk about game development theory, and just you get to do programming in a video game, and that's just neat. Game Dev 2 we do in C++. Game Dev 2 is a C++ class. You probably should take it after 41, my advice. And so, like, if you were going to take this over summer, take Game Dev 1 this summer, and then take Game Dev 2 next summer, and then you would have 45 under your belt at that point, and then you'd be pretty good. Okay. And like Aaron says, it's like CSI Extended. Like, I work a lot of extra material in computer science into them. And so the students get to see things that they didn't even know were possible in C++. Like, oh, I didn't know this was a thing. What is mutable? What is structured bindings? What are all these, things that just don't come up under normal, homework assignments? And then it really gets to push your computer science knowledge to the next level. And then finally, while you are like over summer or over Thanksgiving or something like that, if you want to get good, right? If you're actually serious about computer science, kitty. If you want to actually get good, it's purring now. If you actually want to get good, you need to be working, sort of like, what's the right? Oh, dude, just claw me. Hey, he was like, pay attention to me. It's like I had my finger just dangling down like that, and he just went clawed me. I'm gonna get rabies now and die. All right. So if you want to get good, you need to be practicing constantly. And so there's a lot of different ways you can get the time in, the experience in to actually get good at things, right? You need to find a project that interests you, to code it. It's like, I don't know what's going on back there. It's like the closest thing in computer science is like learning a foreign language. It's not like science. It's not like math. Although it uses science, it uses math. The cat's gonna pounce on him. Yeah, that's funny. The closest parallel really to computer science is like learning a foreign language. The only way you can get good at speaking in Japanese is by speaking in Japanese. You have to just work at it. You have to study. Like I've got, on my, web browser here, I've got, WaniKani, and I, hit this up, and okay, this is Nanatsu, So I'm constantly, just when I have a little bit of downtime, I'm constantly doing flashcards. I'm constantly working on my knowledge. I study with Japanese people twice a day. But you just have to, you can't just like do the minimum in computer science and expect to get good. Like everybody I know that's good in computer science, like, enjoys it. Like that helps, a lot if you enjoy it. If you enjoy the process of like puzzle solving and problem solving and things like that, it really does help. But there are websites you can do. There's like LeetCode. There is codewars. LeetCode is used a lot for job interviews. This will give you kind of a heads up on like what kind of questions you'd expect to see in a job interview. Job interviews generally cover CSI 41 and 26 topics. This is like probably 75% of all job interview questions you're going to get are going to be like from these two classes. Speaking of Code Wars, you're almost to the top of the clan. Yeah, I need to work more on it then. Code Wars is nice because it has like ranked difficulty. And it's got like belts and things like that. So like you can kind of like level up and get a higher belt. You start as a white belt, you work up towards a black belt, And the coding problems have like different. This is a blue belt question, a green belt question, whatever. And so you get more points the higher the difficulty of the question. So I like codewars better than leetcode myself, just because it's got like a really nice difficulty system in it. There's also Hackerrank, which I don't like anymore. It's like pay to win now, kind of, sort of pay to win, kind of. Like if you fail a test case, it doesn't tell you what the test case is. It's just like you failed test case 7. I'm like, well, what is test case 7? I want to, like, what am I not handling? Like a capital letter? Like what am I failing? And it's like, if you want to find out, that's going to cost you 10 power coins. And you're like, no, I'm not paying to find out those stupid test cases. You know, they give you like one test case for free, and then after that you have to buy premium, and like, no. So I used to like Hackerrank. I don't like it anymore for that reason. It's got its own digital currency. I'm like, you know, one of the nice things about it is that like it integrate, like you can put your resume on it, and so like people can like say, all right, give me everybody in Fresno that has level 10 C++ knowledge, whatever, and it'll pull resumes for you automatically, and then you can get job offers through it. But it's definitely a pay-to-win site now, and I don't like that. So, yeah. So if you want to get good, and then just like work on projects for fun on your own time. Like this is like, I'm dead serious about this. You're like, what? Like, yeah, like most good programmers I know, like have some project they work on, you know, and students ask me sometimes, like, well, what should I work on? You know, I'm like, I don't know, what interests you, you know? And so like one guy's like, I like working out, I like lifting weights. I'm like, all right, well, you know, make a program that like tracks your weight over time and tracks your gains over time, and you know, you can punch in your calorie count and how much protein you're eating. You know, just make yourself a workout, like MyFitnessPal kind of thing. If you're passion driven, yeah, like that. And people look for that when they hire. Like when they hire, having projects for fun on your own time looks good, you know, because that's, again, what we've kind of associated with good programmers is that they're passionate about it. They typically work on projects. They typically, you know, have something they're doing on the side just for fun, open source. They release it to the world and stuff like that. Like you're building a CPU emulator, yeah. Mm-hmm. Exactly. Or, you know, if you have projects from game dev, usually homework doesn't count for like getting hired. But like if you've done a project and it's like turned into like its own thing, like you can put that on your resume and be like, look, I invented this video, I made this video game, and you can play it here, and you know, check it out, and here's my GitHub, and here's all the projects that I've worked on in GitHub and stuff like that. And that also helps get you hired for sure. But more importantly, it just helps you get good. Okay. Getting good is important. You need to put in thousands of hours, you know, I would say, until you get to like a level of competency where you're like, you know, Aaron or like Mr. Bell or Mr. Juarez or something like that, where like, you know, you can basically say, hey, I want you to, you know, code me up this, and this, and they ask a couple clarifying questions. Like, all right, sure, let me do that for you, and then they're off to the races, you know. Whereas first year students typically need a lot of hand holding. Like, how do I read a mouse click? How do I draw a picture on the screen? How do I, you know, and you know, and that's expected. Like I said, with 40 and 41, you're hired as a junior dev. A junior dev is literally defined as somebody who has a senior that helps them. Like you are not expected to be independent. You're not expected to be able to work on your own. You're expected to work on a team with somebody telling you and helping you and guiding you and stuff like that. So first step's always the hardest. Yeah, absolutely. And getting your foot in the door at a company is the hardest step. After you're in, for example, a friend of mine got hired at like 18 an hour to do programming, which is really bad. Like that's a really bad wage. But he worked there for a year, and then they're like, okay, and they just knocked him up to 30 an hour, which is still not great. It's still terrible wages as far as computer science goes, but he was unemployed, and so he's now making $30 an hour, and you know, he can, you know, pay for gas and everything else. Oh yeah, TS 100 is another thing I like to recommend. Or basically like all Zachtronics games. All of the games by Zachtronics are like pretty fantastic. TIS 100 is a game that you're programming in assembly. So it's literally a video game that you are programming multi-core CPUs in assembly. Very simple cores, but cores nonetheless. And then you run it, and like this program here is like drawing like, I don't know, happy face or something. I don't know. And you have to do it in the fewest numbers of instructions, the fewest number of cycles, things like that. And that's actually really good at training your brain in like how to program and how to critically think, how to break down problems. Shinjin IO is another really good game. But like all of his games like kind of have that little element of like they're kind of teaching computer science in a game, right? And there's a little bit of a story and things like that. I would highly recommend them if you're into like video games and stuff like that. They're a lot of fun. There's also 7 Billion Humans. If I could snap this window over, thank you.
Hey, you! Are you a hard-working farmer? Never need to work again. Need to do whatever you want.
Creating jobs.
You want jobs? You will have jobs.
Okay, so that is again a programming game. They also have Human Resource Machine, which is also a programming game. They're kind of simplistic. They're more like for elementary school kids, kind of. My daughter hates it. It's not too easy for her, maybe, or maybe just she doesn't want to be a programmer. Either way, but yeah, like Human Resource Machine and 7 Billion Humans are both programming video games. Grasshopper is another one. Some other ones. Opus Magnum, kind of. Shinjin IO is a lot of fun. I love this game a lot. So again, you're programming in assembly. Like this is assembly here, and you're like actually building like devices and stuff like that. It's got a fun solitaire game in it. A little bit of a story. So, yep, that's kind of what. No, okay. Actually, assembly, yeah. Okay, so that is two-factor authentication on GitHub is just a disaster. So that's it for today. So I would like to encourage all of you guys, even if you're not a computer science major, take 40 and 41. If all you take is 40, you're going to forget it. You're not going to be able to program in the future. If you take 40 and 41, even if you're a math major, physics major, you're going to have the skills needed to get through the programming in MATLAB or physics simulations and things like that. This is recorded. Yeah. Why you want to watch this later? Gonna send it to your nephew. Yeah. If you're a computer science major, take all 4 of the grain classes. Like you basically have to. If you're gonna transfer. I highly recommend you guys all take game dev. Game dev will just enhance and make you better. Critical thinking, if you need a critical thinking GE. And then just on your own, just be constantly working on projects and games and things like that. It's just like me in Japanese. Like I'm just constantly, I've got books that I read, and I've got apps on my phone, and I've got different flashcard apps that I do vocab on, and I talk to people, and I've got a friend in Japan. And you just have to keep grinding it. It just takes a lot of effort to get good at computer science. If you're not good at computer science, you shouldn't be right now. You're only in first semester. Like you shouldn't beat yourself up if you're not good, because or what 8-9 weeks in right now. You're not supposed to be good right now, but you need to kind of develop that habit of just like staying on the ball and working and getting good. You're not. That's fair. Like it's week 8 of intro to programming. It's fine. You're not expected to be. What you're learning right now is all the different tools of computer science. It's like you're building a house. And you learn how to do a saw and hammer a hammer and like use a drill, a screwdriver, and then somebody shows you a house and like build it, and you're like, I don't know how to do that. I know how to use these tools, but I don't know how to build a house. And that's what the 4 years of computer science are about. The 4 years of computer science are going to take you from now where you're like, I know how to do a for loop, but I don't know how to do World of Warcraft. You know, like there's kind of a gap there. Like, I don't know, and as time goes on, your brain kind of expands and you learn how to break problems down better. And you learn how to like think about a problem and solve it in different pieces and reassemble the pieces together. Right now, everything you need to know to do World of Warcraft or Microsoft Office or, program a Tesla. Like, everything. You just don't know how to put it together, right? Tesla, if you work for Tesla doing self-driving cars, they're going to be programming in variables. They're going to have algebra. They're going to have if statements. They're going to have for loops. They're going to have functions, right? That's the basics of computer science. Those things right there. They just are putting them together in ways that you don't know how yet. And that's just something that comes partly through classes. Algorithms teaches you different ways of solving things, but also it's just a lot of practice, and your brain will just grow and stretch and expand over the years of doing it. And it takes years to get good. Okay. So you're using a nail gun with safety pins. This class is made for people who don't know it, so embrace it and the failures that come with it. Yeah, just embrace not knowing that much, and just realize you're at the base of the mountain. It's a long climb. It is, but I try to make it as gradual a climb as possible, so there's not like a really sharp cliff that you have to climb up suddenly. It's gradual increase in difficulty and complexity over the 2-3 years you have here, and then it'll continue on into CSU or the UC system or wherever you go. Okay, so stick with it. Ganbatte, do your best. I believe in all of you. You can do it. Peace.